Okay, Wes, so I see that you want to talk a little bit about a logical snapshotting capability called full instance. Is that right?
That's correct.
All right, take it away.
All right. So a full instance snapshot is a point-in-time copy, and it uses a copy on write action, or what we refer to as a logical point-in-time copy rather than a full physical like our traditional snapshot utilities. So one of the key things with this is it does require the enterprise license, and it is built into Veritas Volume Manager. And we're going to build an independent volume for this that's going to contain our change data. So this other volume we call a snap vol. And when we start this snapshot process, we use a utility called vxsnap. And when I start this, I'm going to get a series of pointers that point to my original data in my original data set. Now, as long as this data does not change, we're going to maintain pointers here to point to our original data. But if data does change, say for example, we change our E data here, before these data blocks are actually changed, we do that copy on write action where we're going to have the original data written to our point-in-time copy volume here, and then the blocks here will be updated. When we go to read that data, if I'm reading data that has not changed since the point-in-time copy was taken, then we get it from the original data set. We follow the pointers over. But if the data has changed, we get the changed data, the original data, from my point-in-time copy. Now, one of the features of a full instant is we start out with pointers, we get instant access to it, but it's also synchronizing in the background. So eventually, this does become a full copy. And the advantage of having a full copy is we can migrate this away from this machine, an off-host processing mechanism. We can create a separate production environment. It'll be a full copy of our data. Okay? So we get the advantages of the pointers, the copy on write action, so we can start using this immediately, but we also get the advantages of a full physical copy, so for migration purposes and stuff.
So really, we're getting the best of both worlds here. We're
Exactly.
being able to start a snapshot and be able to use it immediately, if I understand this right. But in the end result is that our logical copy will now eventually become a physical copy.
That's right.
And it can be used for the traditional off-host types of processing or anything else that you would want another copy for, right?
Exactly. We also have the capabilities of refreshing this at any time. We can use this for whatever we want, and then we can do a refresh operation that brings this immediately up to date because all we're doing is creating new pointers.
Fantastic.
Okay? And we can also restore in this direction, but we need to understand that if we don't have all the original data here, we cannot restore to this if the entire data set is lost. But we can go back in time by restoring the original data that's here to this as long as this data, these disks and the volumes are still intact and capable of access.
Well, great. Thanks a lot, Wes. We appreciate it. Now we can see a little bit of how to use this particular copy. So thanks very much.